Hello everyone. Today's discussion is for class 9 and is the continuation of chapter 2. Today we are going to discuss about types of chemical reactions. So in general there are 4 different types of chemical reaction. The first one is direct combination or synthesis. The second type, decomposition. The third, displacement, and the fourth is double decomposition or double displacement reactions. So, direct combination. Let's discuss in short. First, after that, we will be discussing them in detail. So, in direct combination or synthesis, the term combination itself says about such types of reactions. In such type of reaction, 2 different element or compound, they combine to give you one single product. Okay? In combination, 2 elements or compounds, they combine to form one single product. The second type is decomposition. In decomposition, these reactions are just the opposite of direct combination. So here, one single compound will break up into 2 or more products. Like here, AB is one single compound. Now, after the reaction, this has given C and D, and it could give you more than 2 products also. So such type of reactions are decomposition reactions. In displacement reaction, look in this example. Here, from this compound, here the compound is BC. Now this cation of this particular compound, that is BC, is replaced by A. So in place of B, what has come? A has come. Now such reactions in which one of the cation or anion is displaced by another active element is known as displacement reaction. Now the fourth type of chemical reaction is double decomposition or double displacement reaction. Now here, 2 different compounds. AB is reacting with CD. Now in this reaction, both of these reactants are in solution state. Now here, how does the reaction take place? Here, the exchange of radicals. Now see, I'm circling the anion part. This is cation, this is anion, this is cation, this is anion. Here, this B will come with C and this D will go and get bonded with A. So as a result, now in place of B, what has come? D, and in place of D, this B has come. That means there is double displacement. Now such reactions are known as double decomposition or double displacement reaction. So here the product after the displacement is AD, and the second product that we have is CB. And please remember, while writing the product, the cation is always written first. So this is positive cation, this is anion. So positive, the cation part is always written first, then the anion. Okay? So these are the 4 different types of reactions. Now let's discuss them in little more details with certain examples. So first, direct combination or synthesis. We will be discussing about the first type of reaction. Now, in direct combination, as I told you, 2 different elements could combine to give you one single product. So let's take an example where 2 different elements combine. So two elements combine to give the compound. Now in this reaction, two different elements. Okay? So in this reaction, see, this carbon is an element. So as oxygen, okay, oxygen in gas phase will combine with carbon in solid phase. This is solid, this is gas phase, to give you one single compound, that is carbon monoxide. Okay? So you can balance this equation. Okay? So here, this carbon element is combined with oxygen element. So two elements are combined to give you one single product. So in the second time, under direct combination could be combination of one element and one element and one compound. So one element combines with one compound to form a new compound. Example is carbon monoxide combining with oxygen to give carbon dioxide. So carbon monoxide, it's formed between two elements, therefore it's a compound. This compound is combining with this element to give you a new compound, that is carbon dioxide. So one element can combine with one compound to give a new compound. So this is second type. Now there is also third type where two compounds combine to give one new compound. The third type is C. So two compounds combining to give new compound. So here the example is very common phenomenon, okay, that is photosynthesis. In photosynthesis what happens? Carbon dioxide, which is a compound, combines with water. This is also a compound. So this is one compound, another compound. They are combining in presence of sunlight. So last time also we had discussed this reaction to give glucose C6H12O6 and also oxygen. So if you have to balance this equation, here 6 carbons are there. There were 6 carbons, 12 hydrogens. So if I write 6 over here, then it becomes 12. Now 6 into 2 is 12. 12 plus 6 is 18. So 18 oxygens are there on the left hand side. Now here we have 6 oxygen. So if I write 6 here, that means 6 to the 12. 12 plus 6 is 18. Now this equation is balanced. So here two different compounds are combining in presence of sunlight to give one main product. Okay, this is one main product. This is a gaseous form. Now we can also have another example of this type of reaction, that is when ammonia reacts with HCl. So this is a compound and this is also a compound. So they react to give one particular compound, that is ammonium chloride. So this is also a type of combination reaction where two compounds combine to give one new product, that is one new compound. Now this was all about the first type of reaction, that is combination. Now let's discuss decomposition reaction. Now in decomposition reaction, as I told you, decomposition reaction is just the reverse of or the opposite of combination reaction. So, decomposition reaction. Now, here, this is the second type of reaction. Now, under this, also, this can be categorized into different types. Like, whenever you have one particular compound, that would give you that would give rise to two different elements. Okay, let's discuss that. So the first one is compound decomposing to give two elements. Okay, now example is water. Whenever electricity is passed in water, what will happen? Water will break into its constituent elements, that is hydrogen and oxygen. Okay, here this one particular compound is decomposing to give two different new elements. Now the second example is a compound can break to give compound decomposing to give one element and a compound. For example, potassium nitrate. Whenever potassium nitrate is heated, this is the sign for heat. Whenever it is heated, it decomposes to give two products. One is potassium nitrite and the other one is oxygen. So this is potassium nitrate and this is, please remember, this NO2 is known as nitrite. Okay. Now let's focus on this main part. This is NO3 is known as nitrate, RATE, and NO2 is known as nitrite. So this one compound, whenever it is heated, it gives you, this is a compound, it's potassium nitrite. Okay, this is one compound and one element. Now the third type is compound decomposing to give two compounds. Now this is third type under decomposition reaction, compound decomposing to give two compounds. Okay, so let's discuss it with an example. Calcium carbonate whenever it is heated, now it decomposes, it breaks up to give two different compounds, that is calcium oxide and carbon dioxide. So this is solid instead, this is also solid, and this is, as you know, it is gas. So see, this one particular compound, whenever it is heated, it decomposes to give two different compounds. One is calcium oxide, another one is carbon dioxide. So generally, this decomposition reactions takes place in presence of heat, electricity or light. Please remember that. Okay? So three conditions are either presence of electricity, heat or light. Now let's discuss about the the third type of reaction, that is displacement reaction. So we have discussed two different types. First, combination. The second one is just the opposite of combination, that is decomposition. Now we are moving to the third one. The third one is displacement. Displacement. Now, as I told you, in displacement reaction, a more active element will displace a less active element from a compound. Okay? Please listen to it very carefully. More active means the one which is stronger will displace the weaker one. So let's discuss here with an example. So whenever zinc is treated with copper sulfate, okay? Whenever zinc is treated with copper sulfate, now since zinc is stronger, then what will happen? The zinc will displace this copper out of this particular compound. So in our product, in place of copper, what we'll have? We'll have zinc coming here, zinc sulfate. So zinc sulfate plus copper. Another such example is magnesium reacting with sulfuric acid. So magnesium is more active than hydrogen. Therefore, this magnesium will substitute hydrogen from sulfuric acid. Therefore, we will be getting MgSO4 plus hydrogen gas. Now, here is a question. Okay, you understood a stronger one or a more active element will displace the weaker element. But how will you know which elements are stronger and which are weaker? Now for that, you have a series that is known as activity series or the reactivity series, in which different elements are placed according to their decreasing reactivity or activity. So for that, to remember that, there is a trick how you can easily remember that. So let's discuss that. So, as I told you, activity series. Activity series. So, in activity series, you have to remember one simple trick, that is this simple sentence first, okay? Please look at it properly. Please stop calling me a zebra. Please stop calling me a zebra. It's like hating. It's like hating cool smart guys. Okay? Now, once you remember this particular sentence, you can arrange the elements according to their activity, reactivity or activity order. So please stop calling me a zebra. It's like hating cool, smart guys. So P implies for potassium. So I hope you have noted down this one. So let me write it here. P for potassium. K as for sodium, Na, and this C for calcium, after that comes Me, M for magnesium, A stands for aluminium. So I am continuing this series here. So after A, what you have? Zebra. So Z stands for zinc. So I am writing the symbol. Okay now. It's ITS. It stands for iron. Iron is Fe. So L stands for lead, that is Pb. Heating, H stands for hydrogen. H stands for hydrogen. C stands for copper. S stands for silver, that is Ag. And finally Z. Z stands for gold. Gold is Au. So I have written the activity series according to the sentence. Now if you remember the sentence, then you can easily remember the series as well. Now see, this potassium, since it's placed at first, so this is the most active element. Then comes sodium, then calcium, magnesium, aluminium, and the list. See, as you go down in the series, what will happen? The reactivity or the activity keeps on decreasing. That means if you have, so suppose last time we discussed this zinc reacting with copper sulfate to give zinc sulfate plus copper. So here, look at the position of zinc. Zinc is here. And look at the position of copper. Copper is here. That means zinc is placed above copper in the series. Therefore, this is more active. Therefore, means it is more stronger. Therefore, it displaces this copper from copper sulfate, and finally we have zinc sulfate plus copper. So hope this way of remembering will help you out. Now this is for the mostly these are cations. Now for anions, you know about the periodic table. In the periodic table, we have halogen group. Now in halogen, the first member is fluorine, then comes chlorine, then bromine and iodine. So as you go down, here also react or activity decreases. Here also what we had, as you went down, the activity decreased. Okay, so this was all about displacement reaction. Now let's discuss about double decomposition reaction. The fourth type is double decomposition or double displacement reactions. So now, in such type of reaction, generally what happens is two different compounds are kept in solution, okay, and there is exchange of radicals taking place to form the product. Now, this double decomposition can be categorized again into two types. One is precipitation. Precipitation reactions. Last time also we had discussed about precipitates. Okay, now let's take the same example that we had discussed in our last class. That was sodium chloride. Whenever treated with silver nitrate, we get AgCl plus NaNO3. This is the precipitate and it is white curdy precipitate. Now here what happens? See, I told you this chlorine and this nitrate, this chloride and this nitrate. This is cation, this is anion, this is cation of another compound and this is anion of another compound. So there is exchange of anion. See, if you are exchanging anion, then you exchange only the anion part. This Cl will be coming to this place and this NO3 will be going to this compound. Therefore, you get this product. Okay? This is the example of precipitation reaction, which is one of the type of double decomposition or double displacement reaction. The second type is neutralization reactions. In neutralization reaction, what happens is whenever an acid reacts with a base, it always produces salt and water. So those reactions in which acids and bases they react to form salt and water as the only product, then that reaction is known as neutralization reaction. So let's take one simple example. NaOH, you know it's a base. OH, whenever a compound has OH, that means it's a base. Whenever it reacts with acid, HCl, and what will happen? See, as I told you, this is also double displacement reaction. NaCl plus water will be formed as the product. Now, how can you arrive at the product? This OH and this Cl will be exchanged. This will be going here and this OH will be coming to this part. So you will be getting HO. That means H2O. H2O. Okay? This is salt and this is water. So neutralization reactions are those reactions in which acids and bases they react to form salt and water as the only product. So these were the four different types of reactions. Now your assignment would be to complete the exercise just after this particular talk.